Hi students, welcome to the online classes. Today we'll discuss about the new topic, new subjects, which is related with the problem solving technique, right? And which is related with the BCA first SEM for Vijayanagara University, Ballari, and also it is implemented in the Kopla University, Kopla. Let us start with a subject that is problem solving technique. This is one of the subject you need to study in a BCA first SEM in the academic of 2026 and 27. Course code is 26 BCA 11. In this, you need to learn the unit 1 and as well as the unit 2 and unit 3 and 4 and 5. Total number of units we have a 5 here. Out of this, first one is we need to learn about the problem techniques we need to learn. And second unit, we need to learn about C programming language. And third, in the C programming language and third one, we need to learn a structured programming concept we need to learn in terms of the C program and problem on numbers and modular programming and problems on arrays. These are the topics we need to learn in problem solving techniques. Okay. Without wasting time, let us begin with the lecture series 1. So welcome to online classes with subject problem solving techniques. So the first unit is problems and problem instance. What is problems and problem instance we need to learn here, right? So problem in the sense, what is exactly the problem in the sense? The problem is in computer science refers to a general question or a task that needs to be solved. It is usually described in abstract terms, specifying the input and the described output, but not the method to achieve the solution. What exactly it is going to describe? Describes the abstract terms. It specifies the input and as well as the desired output, but it won't give any kinds of methods to achieve the solution, right? That is what exactly we need to say it is a problem. So example we can understand for this problem is sorting problem. So sorting a problem, it is a name indicates a problem over here. So if that is nothing but give a list of number, arrange them in ascending order. So we have another one that is shortest path problem. Given a graph and 2 nodes, find the shortest path between them. So they will provide input and output and they won't specify any kinds of methods to solve that problem. That is nothing but as a problem over here. In sorting problem, they will provide a 2 list. And what exactly we need to? We need to arrange the in ascending order. But here is the logic things we need to understand which method we should apply to sort up the numbers. That is the first sorting problem. Here they will provide the number and we need to arrange in ascending order. To arrange the ascending order, we need to think out which kind of method I need to apply to sort the algorithm, sort the number, list of numbers. In the shortest path problem also, he has given a graph with the 2 nodes and I need to find out which is the shortest path between them. So they will provide the graph with the 2 nodes and I need to find out the path over here between them, right? So this is kind of things are called as a problem we need to say. Then what is problem instance? A problem instance is a specific case of a problem where all the inputs are specified. It is an actual example that needs to be solved. What exactly instance in the sense? Specific case of a problem where all the inputs are specified. It is an actual example, but that needs to be solved. Example, sorting problem instance. Given the list, he has given 5291. So in the previous example, what he has given? He has given the list of numbers, but don't know which numbers, whether it is an ascending or decreasing. We don't know what kind of list of numbers it is, right? But in the problem instance, by naming of the list of numbers, they given the list over here, 5291, right? That is called a specified inputs. Sort it in ascending order. So he has not given list of numbers, but he has given way of input specified here. He has specified the numbers. In the previous problem, he has not specified what kind of numbers there, but here they are specified over here. So these kind of specifications called problem instance we need to say here. And another one is that is shortest path problem instance we have here. Given the graph below and the nodes A and D, find the shortest path from A to. So here in the previous example also he has given the find the shortest path between them, but he has given the graph and two nodes, but we don't know which graph and which node name it is. But in the problem instance, he has given the node name and as well as the A and B, and I need to find out in between the A and D of the shortest path. So this is they are specifying the specified inputs to get exactly solution for that one. That is called problem and problem. This is the difference between the problem and problem instance. In the problem, we don't know the exact input to solve the specific problem over it. But when you go for an instance, they give some of the inputs, specified inputs to get the exact solution, right? Let us, here is a examples of our problem and problem instance. In the problem, we say it is sorting numbers. In the problem instance, we specified the numbers or specified the inputs. Find the shortest path. But in problem instance, we need to find, they will provide the path, which path we need to find out the shortest path over here. And search in array. We don't know which array, whether it may consist one element, two element, three element, or 10, or 20, 30. But in problem instance, we'll have an element. In that element, we need to search the element, right? So finally, we can conclude that problem is general description of a task, but problem instance is specific example with all input given. This is the difference between problem and as well as a problem instance. I hope this you have understood and you have it is very clear about the problem and as well as a problem instance. For in which situation we need to say it is a problem and in which statement we need to say it is a problem instance. Right? Next. Generalization and special cases. Generalization and special case. So, generalization and special case, that is also called a step-by-step process we need to say in terms of the algorithm in the problem solving techniques over here. So here, generalization and special cases are the two complementary problem solved approaches used in mathematics in as well as computer science and related fields. So generalization, it involves starting from a specific problem or a result and finding a border statement that applies to a wider set of case. Let us see how to solve that one and how to step-by-step process for generalization. First, we need to identify the specific case. Specific case in the sense, understand the problem or theorem fully in its current form with all the details. That is first specifying the cases. Second one, analyze the condition. Analyze the condition. Analyze the condition. Determine which conditions are essential and which are restrictive or can be relaxed. Third one, abstract the problem, replace specific numbers, variables, or parameters with general ones to formulate a generalized statement. And fourth one, formulate the generalized hypothesis. And fifth one, attempt to prove the generalized statement and check if it reduced to the original. So these are the step-by-step where we need to go under the generalization format over here. So we are taking the specific problem and we are finding the wide, that is broad statement we are going to apply over here to get set of cases, right? So here is one of the examples. So we can able to understand within 1, 2 or 3 lines. in specific case, in the sense the sum of first three natural numbers is 6. Generalized statement is the sum of the first n natural number is n into n plus 1 divided by 2. This is the special case difference with the generalized statement over here. So this is all about a step-by-step process. With the generalization, we need to follow the 6 steps. Now let us see what do you mean by exactly a special case it is. Special case involves focusing on particular instance of general problems, right? General problem to simplify the problem or gain insight step-by-step process for specified case. Let us see the step-by-step process for special cases. So here what we need to focus? We need to focus on the particular instance of general problem to simplify the problem and gain insights. So special cases, let us see what are the steps we need to follow. We need to follow the 4 steps. First, we need to start with the general problem. What kind of general problem we need to, what kind of theorems. So everything should be understand in terms of the general. Second one, choose the particular value or a condition. Whether these are the conditions we can able to apply on the particular general problems or not. If it is a value or maybe a conditions, we need to find out over here. And we in this situation also we need to find out the what kind of parameters should be taken for to solve these problems also should be undertaken in this choose for particular value or a conditions, or sometimes we need to say it's a parameters. Third one, analyze or solve the simplified version. That is, solve or analyze using the chosen specific values. Fourth one, use the insight gained. Apply insights or patterns observed from the special case back to the general problem if possible. Right? These are the steps we need to follow in terms of these special cases. So when you go for general problem, that is prove the formula from the for the sum of the first n natural number. This is a general problem in terms of special cases. In special cases, check the formula for n is equal to 4, sum is 10 and 4 into 4 plus 1 divided by 2 is equal to 10. This is a special case. So this is all about your next. So in next series, we will learn about the types of computational problems in the next lecture series. During this session, if you face any kinds of a problem with this previous slides regarding the problems, problem instance, everything, kindly tell me. You can tell me in terms of the comment box. You can place the queries regarding for this slides over here, right? Okay, then we'll see in the next lecture series. Thank you. Thank you, Ondita.